right, so welcome back to the deep dive where we, as always, try to, extract the most interesting and useful stuff from the source material
Yeah.
for you guys. And today we're talking about something pretty mind-bending.
Yeah.
How our own rapid technological progress is changing how we think about the search for alien life. And
Right.
I mean, it's a big one.
Yeah.
So the material for this deep dive is a discussion with Kartik from last year, 2023, reflecting back on his 2009 article, SETI and the Singularity. So that's SETI. And this is about future tech and also the search for extraterrestrial intelligence, which we've been doing, since really the dawn of the radio age.
Right. Yeah. I mean, as soon as we could start broadcasting.
As soon as we can start listening.
Exactly.
So our goal today with this deep dive is to understand how all this crazy fast technological advancement affects our view of, alien civilizations out there. Like, what did we think back in 2009 and what do we think now?
Right. And how's that pace of change influencing what we can find and what we expect to find?
Right, exactly. And the idea of exponential discovery, how does that play into this whole thing? One of the things that struck me right away was that Kartik observed back in 2009 that a lot of people in the SETI field weren't really thinking that much about exponential technological growth.
Yeah, that's a fascinating point. Right.
Yeah, and it's like the rate of change, it's not just steady, it's speeding up. And this was something that...
It's accelerating.
Yeah, exactly. And it's accelerating. And the singularity thinkers, the people who are really thinking about, runaway technological progress, they were really focused on this. So.
Yeah. When he talks about singularity, I think it's worth just taking a second to kind of unpack that a little bit.
Sure.
For listeners who might not be, as familiar, it's basically this idea that you reach a point in technological advancement where the growth becomes so fast, so uncontrollable and irreversible that it leads to changes that are really beyond our current comprehension.
Right. Like we can't even really imagine what it looks like on the other side of that.
Exactly. And I think what's important for Kartik's argument here is this focus on exponential progress, that things aren't just, changing linearly, they're speeding up.
Right. Yeah. And it seems like he was saying that SETI wasn't taking that fully into account.
Right. It wasn't really baked into their assumptions about how fast we might discover things.
Yeah. So in his 2009 article, he had these 4 postulates. The first one was that he proposed that the expected lifespan of an intelligent civilization is increasing, like they're not.
Right. They're not wiping themselves out as quickly as
maybe
we once thought.
Yeah, they're getting better at not blowing themselves up.
Hopefully.
The second point was that telescopic power was increasing really rapidly. At the time, it was something like 26% per year, although I think he says that it's slower now.
Right. Yeah. It's interesting to see how some of those predictions have held up.
Yeah. And the third one was that we would have confirmed thousands of planets in the habitable zone by 2025. Which
we are now well past that.
Yeah, we are well past that now in 2025, which I thought was really interesting, was that a civilization just a little bit ahead of us technologically would become pretty easy to detect.
Yeah, that's a really key point.
And just for anyone who's not familiar with what the habitable zone is, it's just that sweet spot around a star.
Right, Goldilocks zone.
Yeah, the Goldilocks zone.
Not too hot, not too cold.
Yeah, where the conditions are just right for liquid water to exist on the surface of a planet.
Which we think is pretty crucial for life as we know it.
Right, yeah. So putting all that together in 2009, he predicted that if we hadn't found any, good, solid evidence of aliens by 2030, it would suggest that these civilizations are probably less common than we thought.
Right. And this is where this whole idea of exponential discovery really comes into play, because each year that goes by without finding anything makes it exponentially less likely.
Right, because we're getting so much better at finding them.
Exactly. Assuming that our technological capabilities continue to advance rapidly.
Right. Yeah. And this is where it gets really interesting to me. He kind of connected the dots between that exponential increase in computing power and our ability to build and operate bigger, better telescopes.
Right. So our ability to search is itself on an exponential curve.
Right. Yeah, exactly. Yeah. It's like our ability to discover is increasing exponential.
It's like a double exponential almost.
Yeah. And he even said that around 2009, we could do more searching in a single year than in the whole period from 1900 to 1980, like 80 years worth of searching in 1 year.
Yeah, that really highlights just how quickly things are changing.
Yeah, it's crazy. So one thing, though, that he did mention was that the increase in computing power has kind of deviated from that steep exponential trajectory.
Yeah, at least for now, it seems like it's slowed down a bit.
Right.
Which is interesting to think about in terms of that 2030 prediction.
Right. Yeah, if that slower pace continues, then maybe the number of exoplanets that we discover by then could be lower.
Right, if that computational power trend doesn't sort of pick back up to its earlier rate.
Yeah. But
God.
even with that change in, that specific curve, it's still amazing how many exoplanets we've found.
Oh, absolutely. It's mind-blowing.
Yeah, he said that back in May 2009, we only knew of like 347 exoplanets. And by 2022, we were over 5,000.
Yeah, and as he points out, that's a direct result of these huge advancements in computing power that we've been talking about.
Right. Yeah, because we can process so much more data.
Exactly, and build these incredibly sensitive instruments.
Yeah. So, but he also said that 5,000, that's a huge number, but it's probably just the tip of the iceberg.
Yeah, I think he believes we need a much, much larger sample size.
Right.
Maybe tens of thousands, hundreds of thousands of exoplanets before we can really start to say with any certainty how common intelligent life might be.
Yeah. I mean, it makes sense, right?
Yeah, each new planet we discover is like another data point
Right. Yeah, it helps us build a better picture.
of what's out there.
Yeah. And it's amazing to think about how much our view has changed. Like if you compare it to the time of the Drake equation or Carl Sagan's cosmos back then, exoplanets were just theoretical.
Right, we hadn't actually confirmed any.
Yeah. And now we have thousands of them.
And even though it's still a tiny fraction of the entire galaxy,
Right.
we've examined so much more of it than we ever could before, thanks to that exponential growth in our ability to find these planets.
Yeah, we're casting a wider net.
Exactly.
So, but here's the thing, despite all of that, exponential increase in our search capabilities, we still haven't found any solid evidence.
Yeah, the silence is deafening, as they say.
Yeah. So this is where I think that it's kind of interesting to look at scenarios from science fiction, like, Star Trek.
Right, just as a kind of thought experiment.
Yeah. And he uses Star Trek as an example and says, in that universe, intelligent civilizations are practically next door to each other, like every 10 to 15 light years.
Yeah, they're all over the place.
Yeah. And he even mentions how close the founding species of the Federation are, like the Tellarites, the Andorrans, and the Vulcans. They're all within like 16 light years of Earth.
Right. It's a very densely populated galaxy.
Yeah. So if you connect that to his, 2030 time frame in that original, more rapid technological trend line,
Right.
it's like we should be getting to the point where we can either find evidence to support that kind of crowded galaxy.
Or we find nothing and it starts to argue against it.
Yeah. And if we keep finding nothing, it would suggest that maybe our neighborhood isn't as,
Bustling.
yeah, as bustling as Star Trek would have us believe.
Right.
So he's careful to say that it's too early to say for sure. But the lack of discoveries, even though we're getting so much better at searching, does kind of hint that intelligent life might not be as common as we thought.
Yeah, the silence is becoming a little more meaningful.
Yeah. So this brings us to the Fermi paradox, which is, the apparent contradiction between the high probability of alien civilizations and the fact that we haven't heard from any of them.
Right, the great silence.
Yeah, and he has this really interesting perspective on that. He says that the exponential increase in our search capabilities, combined with the fact that our civilization is hopefully lasting longer and not destroying ourselves,
Right.
might actually make the Great Silence more understandable.
Because it could be that civilizations tend to last longer now, and because our ability to find them is growing exponentially.
Right?
The silence might suggest that they were never really that common to begin with.
Yeah, which raises this really interesting possibility that we might be one of the first or one of the very early intelligent civilizations in the galaxy.
It's a humbling thought.
Yeah, and he points out that as our search power keeps growing exponentially, if we still don't find any evidence of civilizations that are much more advanced than us,
Right,
it's going to become harder and harder to believe that they're out there.
right. The longer we look and find nothing, the more weight that silence carries.
Yeah, and just to kind of highlight the scale of what we're talking about here.
Yeah.
He mentions other galaxies.
Right.
And the distances involved there are just on a whole other level.
It's mind-boggling.
Yeah, it makes interstellar travel within our own galaxy look easy.
Yeah, relatively speaking.
Yeah, so detecting life in other galaxies, that's a whole other
challenge.
Yeah, so I guess to kind of bring it all together, the main idea here is that the exponential progress of our own technology is fundamentally changing how we approach the search for alien life.
Absolutely.
It's not just about having better telescopes. It's about the rate of discovery and how that affects the conclusions that we draw from the silence.
Right, and how that rate of discovery is itself accelerating.
Right. Yeah, it's accelerating on top of accelerating.
Driven by these incredible advances in computational power.
Yeah, so that leads to the big question that we want to leave you guys with.
Yeah, what does all this mean for us?
Yeah, given everything we've talked about and this emphasis on exponential discovery, what does the continued absence of evidence by 2030 or even beyond really tell us about our place in the universe?
Right, is it just a matter of time before we make contact?
Right.
Or is this a sign that we're more alone than we ever imagined?
Yeah, is it a temporary quiet period before a huge breakthrough, or is it a sign of something much more profound?
It's a question worth pondering.
Yeah, so think about it. Consider those original ideas that Kardec had back in 2009. Look how far we've come since then.
And where we might be headed.
Yeah, and what the future holds for our understanding of the cosmos.
Exciting times.
Yeah, thanks for taking this deep dive with us.
Absolutely.